So in simple token authentication, the process works like this. The developer is going to come to you and request an API key. This may be an application process. This may be just filling out a form on the website and you automatically give them an API until they start abusing the service. But there's going to be some process and they need to get a magic string that you're going to use to identify who they are. By making this request, you're going to supply them with an API that's that magic string and then some shared secret that you both can use to do encryption. The idea here is that you're going to be able to have them encrypt something special on their side, pass in the result of the encryption, and then you, having that same shared secret on the server, can encrypt the same piece of information and validate that they know about the secret. This process of requesting an API key and getting a shared secret is a one-time thing. This does not have to happen every time a user uses your API. This is only going to happen when they register as a developer for your API. The developer is then going to make an API call to actually request a token, and this request will contain some information that you can use to validate who they are. This request is then going to be confirmed that yes, this is a valid user, we haven't blocked them, the credentials they've given are correct, therefore they know the shared secret is essentially what you're doing, and you're going to return to them a token. Now this token is another magic string that you're going to be able to just put together and validate that they're going to use to call your API. This token is going to be tied to a timeout. This token may be good for 7 days, 7 hours, 7 minutes, depending on the volatility of the data and how long you want to leave a window open for attack. Some APIs make this work for 2 hours, some of them make it work for a full day, but anything longer than that can really open you up to problems. This token is either supplied in a header or just as a query string parameter, depending on how you're working with it. If you're developing a richer API, you're probably going to want to support both mechanisms. The query string ends up being easier for the first-time developer of an API, but it's usually a little cleaner to go ahead and put it in the header later. If you look at the way that Facebook or GitHub and some of those other APIs work, they usually support it in both ways. We're going to just do it in the query string to simplify our naive implementation of token authentication so you can see it work. So let's start by implementing the token controller and request so we can see how we want to store these things and keep them around. If we come back over to Visual Studio, we're going to start by actually creating a new controller that I'm going to call a token controller. In our case, the data access layer, the repository, already supports the idea of storing auth tokens as well as having API users, and so we're going to base our interaction with data that's already in the database. So we're going to, like all other controllers, change the base class to base API and then just generate a new constructor that takes our repository, so that our other parts of our API can actually have access to them. Next, we need the call that's going to return back a token if the information is correct. And the best way I think to do that is with a post. We're actually creating a new token in this case, so post is the correct verb. So let's go ahead and create a public method for post. Let's go ahead and return a response message, because we want to be able to return rich information like unauthorized, bad requests, those sorts of things. And our post is going to take as the body of a message a JSON object that contains the credential information. So in this case, I'm going to use that from body, as we've seen a number of times already. And I'm going to create a new class called a token request model that includes that information we need that forms that request. And I'll just call that model. And I'll just use refactoring, and let's generate a quick version of this inside of the models folder. Now that we have that model, we're going to want to pull some information out of it. So let's go over to the token request model and just add 2 properties that we're going to need. We're going to need a string that represents the API key. This is that magic key that they were granted when they registered with you as a developer. And we're also going to ask them for a signature. This is going to be a string that's going to contain information to verify who they are. This typically is going to be something that's going to be encrypted on their side and then like encrypted on our side and compared to make sure that we both have the same shared secret for encryption. We're going to implement this in a fairly naive way back here in the token controller. First thing we're going to want to do is get who is the actual API user. So let's get the user out. When I say user, I mean developer. I'm going to go to the repository in our case, and we're going to get API users and just look for our specific user. Our app ID equals model.API key. We're going to attempt to find the first user that has the API key that we're passed in. If user doesn't equal null, we're going to continue down here. And let's go ahead and do the typical, let's capture this all in a try, catch, and we're just going to return request.create error response, bad request, and we'll go ahead and pass them in the exception in our case. So if they get through the whole process without an exception, we'll go ahead and do the same thing, request.create response, but just say bad request as well. But we're not going to include the error information because we don't have any in that particular case. Now that we have that user, we can actually get out our secret, right? We can look at this secret and be able to figure out whether the signature we were handed matches the information that we're using from our secret. For brevity, let's talk about confirming that secret. I'm just going to paste in some code and let's talk about what it's doing. In this case, I'm going to take the secret and I'm going to get the raw version of the secret. In this case, I'm going to convert it back from a base64 encoded string. And then I'm just going to use SHA-256 as my cryptography piece. And I want to compute a hash just simply based on using this secret that both sides have, and I'm just going to create a hash based on the app ID or the app key that is being passed in. Basically what we're doing here, and this is a very naive implementation, we're going to want to do something more sophisticated, is we're asking the user of the API to encrypt the app ID with the secret we gave them, and we're going to agree beforehand, and that'll be an SHA-256 encryption. And we're going to get a hash, and then we're just going to compute a signature on our side of what is a base64 version of that hash. Then we can just simply say if signature equals the model.signature. So we're going to say, did we both get the same result? We've agreed ahead of time to encrypt this string in the same way, so we're going to compare what they gave us to what we just computed to see whether they are a valid actual user. If they are, then we're just going to generate a brand new token. So the first thing we're going to do is build up a string that contains the different pieces of the token. In this case, we're just going to concatenate the app ID from the user as well as with the current date in UTC form. This will just be a raw string that we're going to use to generate a unique string for our token. Next, we need the bytes of that token. And we'll just get that by saying UTF-8, get bytes, and we'll pass it in our raw token information. We're getting a version of the byte for the string because we need to send it through our cryptography provider in order to produce an encrypted version of it. Otherwise, people could very simply just craft these. So our token ends up being provider compute hash and passing in that raw array of bytes. Once we have this token, we can go ahead and build our auth token. This is the object that we're going to store in the database. So new auth token, and the token itself could just be this token, but of course this is expecting a string and this token is an array of bytes. So we're just going to want to convert this into a web-friendly string, which we can do with convert to base64 string. And for our expiration, we're just going to compute something that is going to give this object a lifetime. In our case, we'll just compute something 7 days from today. So we'll say date, time, UTC now, add days, and that way our token will be good for 7 days. You may decide that that's too many or too few depending on your use case. You may decide to make this a 30-minute token, or you might want to make it a 2-week token. It really depends on the sensitivity of your data. And finally, we're going to need to set the app user. This is the user itself that owns this token. Once we have this, we can use the repository to insert our new token. And we'll just want to make sure that this actually saves. So if insert and the repository.saveAll, both of those are successful, then we can actually return from this our new token. Now that it has successfully saved, we're going to want to return a response. This response is going to be created because it is a post. Like all the other post calls we've done earlier, we're going to use created as the return type, or a 201. And now we're going to want to pass back in the auth token. But of course, we don't actually want to pass in this entire auth token because it contains information we don't want to necessarily expose the user to. We really just need to give them two pieces of information. The expiration, so they know how long it's alive, as well as the actual token. We can do that by using the model factory.create for our auth token. To go ahead and use refactoring to generate that new method, and then let's walk over to it and actually implement it. We're going to make this public, of course, and what we're going to return from it is going to be an auth token model. Now we don't have this class yet, so we're going to want to create it. So I'm going to use refactoring and just say create a new type. And I'm going to create this new type in our models folder, and of course call it auth token model. And let's head over there and just implement this class. We're going to want a string that represents the token, and a date time that represents the expiration. That's all we're going to return back to the user. And then of course here in the model factory, this becomes fairly simple. We're just going to say return new auth token model and map those back. Token equals auth token dot token. So if we go back over to the token controller now, let's go ahead and build it to make sure we haven't done anything wrong. And it's building. That leaves us with one last step, and that is adding the route. So let's head over to our web API config. Let's create a new route for the token. I'm just going to copy this. I'll call this our token. And all we're really going to have here, because the only thing we're supporting as post, is token. Build it to make sure it works. And now we're ready to actually test it. So we head over to Fiddler. So if we go ahead and test this, we should be able to call token, and let's execute it with nothing in it. And we get method not allowed because we haven't implemented post. So let's go ahead and look at post. Get rid of that authorization header because we're not actually using it for this. And we're going to want to put together a request body that contains, if you remember, the API key. Let's make sure it's valid JSON by quoting all the names. And we're going to also want the signature. A little Martha Stewart action to show you this. So this API key was actually generated and stored when we seeded the database. So this assumes that we've already registered and we're given a magic string for our API key. And then I produced this signature by doing the same thing we did in code a minute ago externally. So that you can imagine whoever calls this is going to have to do exactly this. Give us the API key and give us that signature. And hopefully if we execute it, the result of this is going to be a token we can use. Now what's interesting here that'd be important to understand is that we just requested another token. The proper thing probably when we requested a token is to go look for all the old tokens and eliminate them. So this API key is only responsible for a single token at a time. And the rules for that really depend on what you want it to be. It may be that you're going to allow 5 or 10 tokens at a time, or it may be that you only allow 1. So the cleanup of those old expired tokens is really going to be up to you. Now that we have a way of generating the tokens, let's talk about actually handling the token-based authorization in our filter.